Alright, so for this video, I'm going to be solving the equation 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. So, I'm going to be solving for x in this equation, as that is the only variable. And now for my solution. I'm going to start by rewriting my equation down here so I have more solving space. So my equation is 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. Now from here, I'm going to be using the property of exponents that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 8 to the power of x plus 9, and I can rewrite this as 8 to the power of x times 8 to the power of 9. And this is equal to 9 to the power of x plus 8, which I can also rewrite as 9 to the power of x times 9 to the power of 8. Now from here, I'm going to divide both sides by 9 to the power of x. So then for my right hand side, these two cancel out, and I get 8 to the power of x times 8 to the power of 9 over 9 to the power of x is equal to 9 to the power of 8. Now I'm going to divide both sides by 8 to the power of 9. So then these two cancel out, and I get 8 to the power of x over 9 to the power of x is equal to 9 to the power of 8 over 8 to the power of 9. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x over 9 to the power of x is equal to log of 9 to the power of 8 over 8 to the power of 9. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log 8 to the power of x over 9 to the power of x is going to equal log of 8 to the power of x minus log of 9 to the power of x. And I can use the same property of log 9 to the power of 8 over 8 to the power of 9 to make it equal to log 9 to the power of 8 minus log 8 to the power of 9. Now, another property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is the same thing as b times log a. In this case, I can use this property for all my terms over here. So to start, log 8 to the power of x, I can move this to the front, and I get x times log 8. Now I have this minus log 9 to the power of x, I can move x to the front, so I get x times log 9. And this is equal to log 9 to the power of 8. I can move 8 to the front, so I get 8 times log 9 minus log 8 to the power of 9. I can move 9 to the front, so I get 9 times log 8. Now, because both of these terms have x in them, I can simply factor out x. So I get x times log 8 minus log 9 is equal to 8 times log 9 minus 9 times log 8. Now, we obviously want to find the value of x, and the only way to do that is to get rid of this log 8 minus log 9 by dividing both sides by log 8 minus log 9. So then these two cancel out, and I get x is equal to 8 times log 9 minus 9 times log 8 over log 8 minus log 9. Now, log of 9, we can simplify this to log of 3 squared. And remember, if I have something in the form log a to the power of b, I can move b to the front. So I can move 2 to the front, and this is going to equal 2 times log 3. Now I can do the same thing for log 8. Log 8 is equal to log of 2 to the power of 3, and I can move 3 to the front, so I get this equal to 3 times log 2. So now from here, I get x is equal to 8 times 2 log 3 minus 9 times 3 log 2, and I have this all over 3 log 2 minus 2 log 3. Now 8 times 2 is 16, so I get x equals 16 times log 3 minus 27 times log 2 over 3 log 2 minus 2 log 3. And all of this is equal to 9.6548. Alright, so in this video, I'm going to be solving the equation 25 to the power of x minus 5 to the power of x is equal to 20. So to solve this equation, I'm going to first start by subtracting 20 on both sides. So then these two cancel out, and I get 25 to the power of x minus 5 to the power of x minus 20 is equal to 0. Now 25 to the power of x, I can rewrite this as 5 squared to the power of x. So I have this minus 5 to the power of x minus 20 is equal to 0. And now from here, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And a to the power of m times n, I can rewrite as a to the power of n times m. So if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m should equal a to the power of n to the power of m. So 5 to the power of 2 to the power of x is going to equal 5 to the power of x to the power of 2. Now I have this minus 5 to the power of x minus 20 is equal to 0. And now I'm going to let 5 to the power of x is equal to y, so I get y squared minus y minus 20 is equal to 0. Now, to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 20. So I get y equals negative 1 plus or minus the square root of b squared, so negative 1 squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 20, all over 2a, so 2 times 1. And this is equal to 1 plus or minus the square root of 1 plus 80 over 2, which is equal to 1 plus or minus the square root of 81 over 2. And the square root of 81 is equal to 9. So I get y is equal to 1 plus or minus 9 over 2. Now this gives me two solutions. I get y equals 1 plus 9 over 2 and y equals 1 minus 9 over 2. So 1 plus 9 is 10, and 10 divided by 2 is 5, so I get y equals 5 as one solution. And 1 minus 9 is negative 8. Negative 8 over 2 is negative 4, so y equals negative 4 is another solution. Now from here, remember how we let 5 to the power of x equal to y. So this means I get two solutions. 5 to the power of x is equal to 5, and 5 to the power of x is equal to negative 4. So let's look at this equation over here. 5 to the power of x equals negative 4. Well, we can't take the power of a positive number and turn it into a negative number, meaning this equation has no solution. And for 5 to the power of x equals 5, to solve this, what most people do is, for other exponential equations, we would have to take the log and do a bunch of other stuff. But as over here, we could just see 5 to the power of 1 is going to equal 5, because anything to the power of 1 is itself. So this is my solution.